Let's start by discussing the main purpose of MARPOL Annex I. The goal here is to minimize the environmental damage caused by oil pollution from ships. Annex I specifically addresses the discharge of oil and oily mixtures, ensuring that ships have the necessary equipment to prevent oil spills. This annex became effective on October 2nd, 1983, and since then, it has played a crucial role in protecting our marine environment. MARPOL Annex I outlines mandatory requirements for the machinery spaces of all ships. It also includes specific regulations for the cargo areas of oil tankers, where the risk of oil pollution is particularly high. Today, we will focus on the requirements that must be followed by all ships. We'll be looking at Chapter 3 of Annex I, which covers Regulations 12 through 17. These regulations provide detailed guidelines on how to manage and prevent oil pollution on ships, ensuring that the environment is safeguarded against the harmful effects of oil discharges. Let's talk about something important that every seafarer should know. Oil residues. Every ship with a gross tonnage of 400 tons or more, built on or before December 31st, 1979, is required to have tanks specifically for storing oil residues, which are also known as sludge. But what exactly is sludge? Sludge is a sediment that forms as a mixture of water, impurities, and leftover fuel and oil. This substance is created during the process of cleaning fuel and oil in separators. The sludge can be transferred directly from these tanks to a reception facility using a standard discharge connection. Alternatively, MARPOL Annex I approved methods for disposing of sludge, such as incinerator, or other acceptable means which shall be annotated in the Supplement to International Oil Pollution Prevention Certificate, Form A or B, which ensure that it's safely and effectively removed from the ship. As per MARPOL Annex I requirements, sludge tanks shall have no connections to the bilge systems. But there are two exceptions. First, if tank fitted with drain, this drain should be controlled by self-closing valves and should be arrangements for visual monitoring of the water, which is coming out from the sludge tanks, leading to bilge water, holding tank. Second, the sludge tank discharge piping and bilge water piping can be connected to each other via a common line leading to the standard discharge connection, provided that under no circumstances is sludge transferred to the bilge system. In exchange for cleaner seas and beaches, the states which have signed the convention are required to provide reception facilities for the oily mixtures that ships are banned from discharging into the sea. To make discharge ashore easier, each ship must have a pipe to deck with a standard discharge connection available. To enable the pipes of reception facilities to be connected with the ship's discharge pipeline for residues from machinery bilges and oil residue tanks, both lines shall be fitted with a standard discharge connection in accordance with the following table. The flange, which is the part of the pipe where the connection is made, has specific measurements. The outside diameter of the flange is 215 millimeters. The inside diameter depends on the pipe's outside diameter that it's connecting to. The flange also has a bolt circle diameter of 183 millimeters. There are 6 slots on the flange, each 22 millimeters wide. These slots are equally spaced around the bolt circle. The slots are designed to extend all the way to the edge of the flange, making it easier to secure with bolts. The flange is 20 millimeters thick and is built to hold pipes with an internal diameter of up to 125 millimeters. It's made of steel or another strong material that can withstand high pressure. This is important because the connection needs to handle a service pressure of 600 kilopascals. To secure the connection, you need 6 bolts and nuts, each with a diameter of 20 millimeters. These bolts should be the right length to ensure a tight and secure connection. Finally, to make sure the connection doesn't leak, there's a gasket made of oil-proof material. This gasket fits between the flange faces to create a tight seal. Annex I of MARPOL establishes requirements for the protection of oil tanks on all ships. Specifically, Regulation 12A addresses the protection of fuel oil tanks. Let's start by understanding that the protection requirements for fuel oil tanks apply to all ships designed on or after August 1st, 2010, with fuel oil tanks of 600 cubic meters or more. All fuel tanks on these ships must be double-hulled to enhance safety. But there's more to it. Fuel tanks also need to be positioned at specific distances from the ship's bottom and sides. These distances depend on the total capacity or the combined volume of all the fuel tanks on the ship. The goal here is to regulate how far the fuel tanks should be vertically and horizontally from the ship's hull. For ships with fuel tanks of 600 cubic meters or more, it's crucial to place these tanks at a certain height above the ship's bottom. This is important to prevent fuel from spilling into the sea if the bottom of the ship gets damaged. The distance by which the tanks must be elevated is referred to as H. This H can either be set at 2 meters or calculated using a formula where the ship's maximum breadth is divided by 20. The final value is the smaller of the two options, but it must not be less than 0.76 meters. Now let's discuss the horizontal distance, which is labeled as W. This is the distance that the fuel tanks must be positioned inward from the ship's outer shell plating at any cross-section of the hull. For ships with a total fuel tank volume between 600 and 5,000 cubic meters, the W distance is calculated using a formula. Add 0.4 to the result obtained by multiplying the total fuel tank volume by 2.4 and then dividing it by 20,000. The minimum distance should be 1 meter, but for individual tanks with a volume of less than 500 cubic meters, this distance can be reduced to 0.76 meters. For ships where the total volume of fuel tanks exceeds 5,000 cubic meters, the rules become stricter. In this case, the W distance is calculated by adding 0.5 to the result of dividing the total fuel tank volume by 20,000. The result is then compared with 2 meters and the smaller value is chosen. However, this distance must not be less than 1 meter. So, the positioning of fuel tanks on ships isn't just about following a standard rule. It's about ensuring that in the event of an accident, the fuel remains contained and the environment is protected. MARPOL Annex I also established requirements for all vessels regarding oil filtering equipment. We can divide these requirements for 2 parts. First part, for ships having gross tonnage between 400 and 10,000 tons. Second part, for ships more than 10,000 gross tonnage tons. If a ship has a gross tonnage between 400 and 10,000 tons, it must have special oil filtering equipment in its machinery spaces. This equipment needs to be approved by the administration and designed to ensure that any oily mixtures discharged into the sea through the system have an oil content of no more than 15 parts per million. For ships that weigh more than 10,000 tons, they also need to have oil filtering equipment, but they must also have an alarm system that warns when the oil level exceeds the allowed limit. Additionally, this system must automatically stop any discharge if the oil content in the mixture exceeds 15 parts per million. Some ships, like floating hotels or storage vessels that stay in one place most of the time, don't need to have oil filtering equipment. Instead, they should have a storage tank that's big enough to hold all the oily bilge water that collects in the bilges. This water stays on board until the ship can safely discharge it at special reception facilities on shore. Now let's take a look at Regulation 16, Segregation of Oil and Ballast Water on Ships and Carriage of Oil in Forepeak Tanks. For ships built after December 31st, 1979, with a gross tonnage of 4,000 tons and above, except oil tankers, and for oil tankers over 150 tons, storing ballast water in oil fuel tanks is not allowed. The systems for fuel oil and ballast must be separate. However, in some cases, a ship may need to carry ballast water in oil fuel tanks for stability, such as ocean-going tugs or large fishing vessels operating for long periods. In these situations, the ballast water must be discharged properly, either to shore reception facilities or into the sea, in accordance with the requirements of MARPOL Annex I, Regulation 15. Specifically, this must be done using oil filtering equipment as per Regulation 14 to ensure the water is treated and meets the permitted oil content limits before discharge. Additionally, every discharge must be recorded in the oil record book, following Regulation 17, ensuring proper documentation and compliance with pollution prevention standards. For ships with a gross tonnage of 400 tons and above, particularly those with building contracts placed after 1982, oil cannot be stored in Forepeak tanks or any tanks located forward of the collision bulkhead. This restriction is in place to protect the ship's structural integrity and ensure safety, preventing oil from being stored in vulnerable areas of the vessel. Regulation 15 talks about special areas, which are specific regions of the sea that need extra protection because of their environment or heavy sea traffic. When a ship enters one of these zones, it has to follow stricter rules. Now let's look at which areas are considered special. The Mediterranean Sea includes the sea itself, along with its gulfs and seas. The boundary between the Mediterranean and the Black Sea is set at the 41st degree north parallel, and to the west it is bordered by the Straits of Gibraltar at 5 degrees 36 minutes west longitude. The Baltic Sea includes the sea itself, along with the Gulf of Bothnia and the Gulf of Finland. Its entrance is marked by the 57 degrees 44.8 north parallel near the Skaw and the Skagerrak. The Black Sea includes the sea itself, with the boundary between the Black Sea and the Mediterranean Sea set at the 41-degree north parallel. The Red Sea includes the sea itself, along with the Gulfs of Suez and Aqaba. Its southern boundary is marked by a line between Ras Ani and Hussein Murad. The Gulfs area refers to the sea region located northwest of a line between Ras Al Had and Ras Al Faste. The Gulf of Aden area is the part of the Gulf of Aden that lies between the Red Sea and the Arabian Sea. Its western boundary is marked by a line between Ras Ani and Hussein Murad, while the eastern boundary is a line between Ras Asir and Ras Fartak. The Antarctic area means the sea area south of latitude 60 degrees south. The Northwest European waters include the North Sea, the Irish Sea, the Celtic Sea, the English Channel, and part of the Northeast Atlantic just west of Ireland. The area is defined by lines connecting specific points that form its boundary. The Oman area of the Arabian Sea means the sea area enclosed by the following coordinates. The Southern South African waters means the sea area enclosed by the following coordinates. So these are the special areas where ships need to be extra careful and follow tougher regulations to help protect the environment. MARPOL establishes special rules and requirements for the machinery spaces of all ships regarding the discharge of oil and oily mixtures, both inside and outside special areas. Regarding discharging outside special areas, any discharging into the sea of oil or oily mixtures from ships of 400 gross tonnage and above shall be prohibited except when all the following conditions are satisfied. The ship is proceeding en route. En route means that the ship is underway at sea on a course or courses, including deviation from the shortest direct route, which as far as practicable for navigation purposes will cause any discharge to be spread over as great an area of the sea as is reasonable and practicable. The oily mixture is processed through an oil filtering equipment, meeting the requirements of Regulation 14 of this annex. The oil content of the effluent without dilution does not exceed 15 parts per million. The oily mixtures do not originate from cargo pump room bilges on oil tankers. The oily mixture, in case of oil tankers, is not mixed with oil cargo residues. All of this requirements not considered to Arctic water. The Antarctic is an extra special area. Discharge of oil or an oily mixture into the sea is banned while inside the Antarctic. Regarding discharging inside of special areas, generally requirements is the same for machinery spaces of all ships. Any discharge into the sea of oil or oily mixtures prohibited. When a ship is en route, any oily mixtures discharge must go through approved oil filtering equipment with an oil content below 15 parts per million and must not come from cargo pump room bilges or be mixed with oil cargo residues on tankers. The only difference is that discharges can only be made inside special areas if an oil content meter alarm at automatic stop system is in use. For ships under 400 gross tonnage, there are two options for handling oil and oily mixtures. Either they must be stored on board for later disposal at reception facilities, or they can be discharged into the sea except in the Antarctic and Arctic waters if specific conditions are met. If you see visible traces of oil on or near the surface of the water around a ship, authorities should investigate as much as possible. They'll check things like the ship's speed, direction, weather conditions, and if there are other possible sources of oil nearby, as well as review the ship's discharge records. Additionally, ships are not allowed to discharge any chemicals or substances that could harm the marine environment, and they can't add anything to the discharge just to bypass the rules. Finally, any oil residues that can't legally be discharged into the sea must be stored on board and later delivered to proper reception facilities on shore. Regulation 17 of MARPOL, specifically focusing on the Oil Record Book Part 1, used for machinery space operations. This is an important document for recording certain actions on a ship. Any oil tanker with a gross tonnage of 150 and above, or other ships at 400 gross tonnage and above must have an Oil Record Book Part 1. It can be a physical logbook or an electronic one, but either way, it needs to follow the format laid out in Appendix 3 of MARPOL Annex I. Now let's talk about what gets recorded. Here's a list of things you'll need to log whenever they happen. Ballasting or cleaning of oil fuel tanks. Discharge of dirty ballast or cleaning water from oil fuel tanks. Collection and disposal of oil residues. Discharge overboard or disposal of bilge water, which has accumulated in machinery spaces. Bunkering of fuel or bulk lubricating oil. Any failure of the oil filtering equipment shall be recorded. If there's an accidental oil spill or an exceptional discharge, you need to note that down too, explaining what happened and why. Each operation should be written down without delay. The sooner, the better. For ships that have an International Oil Pollution Prevention Certificate, these entries must be made in one of the following languages: English, French, or Spanish. The oil record book needs to be stored somewhere it can be easily inspected, and it should stay on the ship for at least 3 years after the last entry. Lastly, the inspection part. Authorities from a country that's part of the MARPOL Convention can check the oil record book when the ship is in their port or terminal. They can even make a certified copy of any entry, which can be used in court if needed. This record keeping might seem like just paperwork, but it's crucial for maintaining compliance and protecting the environment.